Let's take a look. Maybe I read the wrong answer. Then again, maybe you're wrong. Who knows? Taking a look at this thing here. Let's look at what we want to know what the measure of angle x is, which is that angle right there, correct? What do we know? We know this little square means that this is 90 degrees. We know that this angle is what we call supplementary to that angle, which makes it how many degrees? 50 degrees. And we know that a triangle has to equal 180 degrees. So we've got 90 and 50, which add up to 140. You take 140 away from 80, I believe you end up with 40 degrees. Did I read the wrong answer?
No, but there's something wrong about that problem because when you have a right angle triangle, usually the other angles are the same.
No, I would say that's a false statement. When you have a right angle triangle, the angles could be any angles. If these two sides were the same equal distance, then these would be equal sides, but they're not. I can have a right angle, Jack. I can have a right angle, that triangle that looks like that. This still be a right angle, and these angles are nowhere near close. You could have any angle with a right angle. That's not a given sort of thing there. You just have to figure. There's no guesswork involved here. That's why they give you these numbers here. Lucas Espanol. Number 15. Number 15. Most likely. Number 15, absolutely. Let's take a look at number 15. The first thing is do the number. What is 2 to the third power?
8.
8. Let's put it over here. And now you have x to the negative 1 power multiplied by x to the third power. What do you do when you have things and you're multiplying exponents? You add their exponents together. It's x to the second power. And anything to the 0 power is 1. It's not nothing, it's 1. But 1 times all this gives you that. So the y to the 0 power goes away, leaving you with just this. 8x. If something to the 0 power is next to other stuff, you can cross it off because 1 times anything is that stuff.
So would it be right if the y is 0 without it?
Well, that wouldn't be simplified though, because we don't write things to the 0 power. Again, somebody grabbed a piece of blank paper, I would suggest you write some notes to yourself, because unless you got them all right, which I'm guessing a very, very small portion of you did. Rockwell? Love to do 11. Is that on this page or the other? This page? Number 11. A couple different ways to do problem number 11, ladies and gentlemen. What would they be? If you can't figure it out any other way, you can't figure out a proportion any other way, you cross multiply. Which means you take this 20 times x and it equals 35 times 12. And then you would multiply 35 times 12, which is 70, 35, 420. You know that 20x equals 420. Divide 20 into that and you're going to get 21. Now, there's an easier way to do it, probably a little quicker, and that would be to do what? Somebody? Help me out here? What way would give me this answer quicker? Wait, maybe I can't get that answer quicker, could I?
Wow.
I gotta undo what I just did there. What should you, did I get the right answer? Yeah. Another way you could look at doing this is this, people. You know that this first fraction can be reduced. 12 over 20 can be reduced to what? What's that, Nick? 6 over 10, cut them both in half. 6 over 10 can be reduced to 3 over 5. And then, once you have 3 over 5, you go, oh, 5 times 7 is 35, so 3 times 7 is 21. Another way to do that, which to me is a little easier at this point, rather than doing all this long multiplication. But either way, you can always do it cross products way. always. Jackson,
I don't understand how to do number 3.
3. The machine can produce 20 plastic dinosaurs in 8 minutes. How many can it produce in an hour? Well, the first issue we have here is this is in minutes and this is an hour. So instead of talking in hours, you need to make hours minutes. What would you call that? How many minutes is an hour?
6.
So call this, you want to know how many it'll make in 60 minutes. So it's just an equal ratio. It can make 120 in 8 minutes, so that means it could make how many in 60 minutes? Kind of just like we did there. If you can't figure out that, does 120 over 8 reduce?
Yes.
Sure, then do what? Cut them both in half, that's 60 over 4. Does 4 times something give you 60? Times 15. You could cut them in half again, by the way. How about 30 over 2? Does 2 times something give you 60?
Yeah.
30, so 3 times 30 is 900. Would be the top answer. It would make 900 in an hour. Again, if you don't want to do it that way, feel free to take 8 times this number equals that times that. Either way, you'll get 900 there. Correct.
For number 17.
For number 17. Oh, I love this problem. What are they asking you to do in problem 17? Just combine like terms, collect like terms. Remember, x squareds only like other x squareds. They're a little chauvinistic that way. If you have 5x squareds and another x squared, that's 6x squareds. 5 and another one is 6x squareds. Here, you have a minus 3x's and you take another x away. It's like owing somebody 3 x's and then you're going to owe them another x. How many x's are you going to owe them? 4 x's. And you don't have to, unless it says the factor. John talked about this, he took something out of this. This is really as simplified as this gets. Even if you factor it, it doesn't look any simpler than this. So this is just your answer. Should we do number 18 while we're sitting there? Same thing on this one. This time, the only thing you can do is you got to get rid of the parentheses using the distributive property. So it ends up being 3x plus, what's 2 times x? 2x. And what's 2 times a minus y? Minus 2y. Once you get rid of the parentheses, what can you combine? Hannah Nuzo, what can I combine there?
X's,
3x and the 2x gives me how many x's? 5 x's. I can't do anything with the y's because the y's are all by themselves. Don't like to get together with the x's. Like dogs and cats. You won't find them together very often. Some of you probably have dogs that get along with your cats, do they?
I don't know.
Jackson, sir,
I still don't understand how to do number 17.
what part don't you get?
Like, how do you get 6x squared?
How many x squares do I have here, Jackson?
2,
What's the number in front there?
5.
I have 5x squareds, Jackson. I add another x squared to 5x squareds. How many x squareds do I have? 6x squareds.
Okay.
It's like having 5 pennies plus another penny. You know, you could think about that. X squareds as being like quarters, and x's are being like dimes. I have 5 quarters and another quarter. That gives me 6 quarters. I owe somebody 3 dimes, and then I owe them another dime, and I owe them 4 dimes. And it's just, the numbers, when you add, the exponents don't change. If I add 5x squareds and another x squared, I don't get x to the fourths. They don't change their signs or anything. That's like a quarter doesn't double to $1 when you put them together. It's just, I got that much.
But there's a subtraction sign in front of the x's.
Yes, and that's why you owe. Subtracting is owing. Subtraction and negative signs are the same thing. A -3 and a -1 is a -4. Subtraction, negatives, it's all the same thing in the mathematical world. There's no such thing as subtracting with just adding negatives. And column.
I'm confused on number 1.
So let's see if we can clear up the murky waters of your disillusionment. A contractor rents a storage room for tools. The room is 20 feet long, 10 feet wide, and 8 feet high. Find the storing capacity in cubic feet. Ladies and gentlemen, anytime you're looking for either capacity or it tells you it wants something in cubic feet, what do we call that in math? Volume. And what type of a shape is this? A room is a rectangular prism, and that's an easy one because volume is always just the length times the width times the height. It's a box. In other words, it's going to look like this. It is 8 feet tall by 10 feet wide by 20 feet long. Okay. It's just a matter of length times width times height. 8 times 10 times 20. And however you want to multiply that together, 10 times 20 is 200 times 8 is 1600. That's how many cubic feet you'll have in that thing. Did you do surface area?
No, I just multiplied volume.
I'm glad we straightened that out. Sage?
For number 5, when you are doing dilation, is it like up 3 over 3?
Dilation just means you multiply each measurement by 3,
Oh, multiplying?
which would be the same thing, Sage, by the way, except the way you would get confused is that you would always go up 3 over 3 the other way, but if it's a negative, you actually go up 3 and then over 3 the other way. And if it's a negative 1 number, you'd go down 3. So the easiest way to remember, and this is the note I make to myself, if it's a dilation, a scale factor of 3, that means you're going to multiply everything by 3. In other words, this point will become 6 comma 6. This point will become negative 3 comma 6. This will be negative 3, negative 3, and this will be negative 6 comma positive 3. Yep, multiply by 3.
Wait.
Did I do it wrong?
No.
Oh, I'm sorry, be negative 3, sorry. Yeah, this is positive 6, oh no, suddenly I went into the negative mode.
Multiply 3 by every number.
Multiply 3, 6, 6, negative 3, 6, negative 3, negative 3, 6, negative 3. It's a scale factor of 3. How many times bigger would the area of that new square be than the smaller square? Nick? Yes, I have made small progress, baby steps. Why 9? Because you have 2 dimensions. You're tripling it, and you're tripling it again. Tripling it twice, actually. Jackson.
How do you do number 2?
Didn't we do number 2 already? Ah. Although 6 of Simon's answer were incorrect, 85% of his answers were correct. How many questions did he answer? I would suggest at this point you'd use a box. Did you use a
I
box?
did use a box.
Perfect.
Can I,
Let's fill in the box. What are we comparing? Correct to not correct, right?
this,
Correct, not correct, and total. And you've got percentages, and you've got actual.
this.
So, what do we know? 6 were incorrect. So that's the number of actual answers that were incorrect. 85%, Jackson, were
Correct.
correct. So 85% goes here. If you have 85% correct and there's 100% total, what percent is incorrect?
15%.
15%. And what's the question they ask you? How many are in all? So you don't even need the 85 at this point anymore. It is 15 over 100 equals 6 over what number?
That's where
And again, let me tell you, okay, this is just a matter of figuring out the easiest way to do this. You can still do cross products, 15 times n equals that, or you can look to reduce this to see if you can get it down to a number that multiplied will give you 6. What goes into 15 and 100?
5.
So if you reduce it by 5, you end up with 3 over 20. 3 times what is 6?
2.
And 20 times 2 is 40, and that is your percent. 40%. Or 40 problems, sorry, it's not a percent. I was going to say. over 40 problems on a second. Sage, hi.
Can you do number 7?
Most likely.
Because 26.
5 houses in the neighborhood sold for those prices. The house with the highest selling price sold for how much more than the median selling price? All right, well, the highest selling price is pretty easy. What's the highest, Sage? 415,000. Now, the problem is going to come in, you need to find this thing. What is the median of those numbers? And in order to do that, you have to order them from least to greatest, did you?
Yeah.
So let's do that down here on the bottom. Smallest one is 297.5. Next one is, looks like 328, right?
Mhm.
And then you have the 345, and then is the 389. Well, you know the third one over is the median, so that would be the one you'd use, 345. In which case, when you subtract, you get 70,000. You did the wrong median, or ordered them wrong, Sage?
Yeah, I did hard, but I put 389,430.
I don't know why either. I do know that as I was walking around, I saw a bunch of you get these scientific notation problems wrong. Make sure, if they give you something in scientific notation, your answer must be in scientific notation. For example, if you ended up with, on this problem, 12 times 10 to the 7th, that's the right answer in the wrong form. Okay, you need, this number has to be between 1 and 10, so you need to move this decimal from here back a place. Making this one smaller makes this one larger, so your answer should be 1.2 times 10 to the 8th power. Same thing for this one. Well, this one doesn't end up that way. Divide 3 into 4.8, it's 1.6. What do you do when you divide these? You subtract exponents. 8 minus 5 is 3. This one, you don't have to change because that number is between 1 and 10, and it stays that way. You get a collective sigh of relief there, John? I thought so. Jackson.
For number 8, I have 0.00008, not 0.0000.
That's interesting. The diameter of a human hair might be 8 point. What is that number in standard form? How do you change that in standard form?
Well, since it's negative, you have to put the decimals there.
Yep, since it's negative, it means your answer is going to be a big decimal, and you're moving the decimal 5 places. So it's a matter of 1, 2, 3, 4, 5. Decimal's going to go here, and all of these loops are filled in with zeros. 0.0008. A good rule of thumb is this: whatever this number is, one of those numbers is going to get taken up by the digit that's in the problem, and the rest are all going to be zeros. So if it's to the negative 5th power, you know you're going to have 4 zeros. If it was to the negative 15th power, you know you're going to have 14 zeros after the decimal before you get to the number, as long as it was in scientific notation to start with. For example, if I have this 1.5 times 10 to the negative 8th power, I'm going to have a decimal point and how many zeros? 7. Because one of those 8 places gets taken up with this 1. There's 7 left after that. 1, 2, 3, 4, 5, 6, 7, 15. It's only this one you count. Don't count the 5. Because you're not moving it over the 5. Did I do something wrong? Nick?
It was like 1.58.
Doesn't matter. If this was 1.58, you just put an 8 there. There's still going to be that same number of zeros. Because you're starting here with your decimal, coming back 8 places. 1 for the 1, and 7 more for the number to fill in the places. Nick, it could be this: 2.687943842 times 10 to the negative 18th power. How many zeros am I going to have? 17. Doesn't matter what comes this side of the decimal because you're only moving it one place over there to get rid of that. Brandon,
Could be 10.2 times 10.
that's not scientific notation. It
Like,
could be, but that's not scientific notation, so they probably won't give it to you. What are you asking me,
Like,
what are you gonna do with it?
Like,
10.2 times 10 to the what?
Just
Give me a number. Positive or negative? Well, in this case, because there's 2 decimal there, there's gonna be 3 zeros in front of this, because it takes 2 to get to this point and then 3 more zeros. But usually they're not gonna give you this because that is not scientific notation.
what about the positive?
Now to the positive 5, that's a different story, because whatever digits are over here are gonna make up those places. Negatives is usually what we get mixed up on. Sage,
Can you tell me again?
I was hoping you'd say number 9, especially since I just ran over time. For the function y equals x minus 2, make a table of ordered pairs and graph the function on the coordinate plane. Which part did you have a problem with there, Sage? The whole works?
Yeah.
Well, what's our starting point? Making a table. You have trouble with that?
No.
Okay, it's important though, when you make a table, what number always goes to the left? Or what letter? X. This is the x and this is the y side. Sage, where do I get my x numbers? They're your, whatever you want. So pick me a couple or 3, Sage. 4.
5 and 6.
Well, again, I try to pick 0 as 1, maybe a negative, I don't know. So Sage, if I put those numbers in for this formula here, where y equals x minus 2, if I take 4, Sage, you're looking, if I take 4 minus 2, I get 2. If I put 5 in for x, 5 minus 2 is, if I take 0, interesting, 0 minus 2 is negative 2. And those are my points I graph on my coordinate system. X is 4, y is 2. 1, 2, 3, 4, y is 2, there's a dot right there. 5, 3, there's 5, 1, 2, 3. 0, negative 2, 0, negative 2. There is your line. Which strangely resembles the one I drew on the board. Ironically enough. Sage,
Number 12.
love number 12. I like it even more when I see it. We didn't do 12? Alright, what's your question, Sage?
I got one.
Well, what's the first thing you did?
I got rid of 1.8.
By,
Subtracting.
correct, did you make this a decimal? Subtract 1.8, subtract 1.8.
Yeah.
So this is 4.2. So now 3x equals 4.2. Now Sage, listen to me, because this is the important part. I see where you went wrong. When you get the equation down to where the letter's right next to the number, 3 and the x, you get rid of this by division. Okay, you don't subtract it over, because when you subtract it, the x has to go with it. You can't take 3x away from 4.2. Anytime you get to this, the only way to split these numbers up is to divide it out so that goes away. Divide 3 into 4.2, x equals 1.4. No matter what the equation is, you should run across a dozen of those a day, because all our assignments deal with equations. You should have that. Jackson,
What about number 20?
what about number 20? Number 20 says the diameter of a cylinder barrel was 20 inches. When the barrel was lifted away, it left an imprint of a circle on the ground. What was the area of the circle?
What would it be 4 times the diameter?
Well, Jackson, the first thing I would do is look in my notes under area of a circle. Did you do that?
Oh, yeah, I know what it is now. This area is.
See, my question is, why didn't you look in your notes under area of a circle to begin with? You're drawing, when you picked up the little cylinder there, it left an imprint of a circle. The diameter was 20 inches. You look in your notes, and the notes say that the area of a circle is pi times radius times radius. In which case the radius is 10. So it's 3.14 times 10 times 10. which gives you 3.14 times 100, which was 314. And whatever that is, what? Inches squared. Tell me what we got left to do there. Well, I'm hoping you got 19.
Oh, yeah.
Number 10, nobody has issue with. Number 16, nobody has issues with. I would say for number 10, if you went wrong, you didn't read the problem right. Did we do all of the first ones? Number 4, Lucas, did you figure out number 4? 50 yards. Everybody's good with those then?